Okay, yeah, I'm back. I haven't recorded for a couple days here, but let's get back into it here, and let's check the current status of the game and start it up. So we've basically implemented the start animation for the game. So when we start up the game, we just see our little T-Rex character here, but nothing else. And as soon as we press the jump button, the T-Rex jumps and a little fade in animation plays. The ground is shown, and the T-Rex starts running as soon as it gets back on the ground. Yeah, but now we actually need to make the floor move again as soon as the T-Rex lands. And there's a couple ways we can achieve this. And I figured we could do it using an event. So that basically the T-Rex raises an event whenever it hits the ground. And then in our game class here, we can check if this event is raised. We can subscribe to that event and then handle it appropriately, so that in the transition state, we listen for that event. And if the event is raised, we just basically set the speed of the floor and just generally take care of all the stuff that needs to be done for the game to actually start. So what I mean by that is the following. Let's go back into the T-Rex class here. I have to kind of get my mindset back on this game project here. I've been working on some other projects for the last couple days, so excuse me if I'm a bit lost here for a second, but I think I will be fine. So what I want to do here is, like I said, implement an event that is raised whenever the T-Rex falls back on the ground. Actually, when it hits the ground, when it lands. So basically when the jump animation is complete. So let's go ahead and do that. And we're going to need a delegate for encapsulating a method with which we can subscribe to that event. And luckily, we don't have to define our own delegate. I mean, even if we had to, it wouldn't be much of an effort. But luckily, the .NET framework also already provides us with the event handler delegate, which we can use for this. And let me just go ahead and do that. So let's go right here between the field declarations and the properties. And go public event. And let's call it jump complete. Oh, I forgot the type, which would be event handler. And we're not going to use the generic event handler because we don't have to pass any specific arguments. We really only want to raise an event that really doesn't have any arguments. So public event handler, and let's call it jump complete. There we go. And typically an event is raised in a protected virtual method. Let's call it on jump complete. And here we're simply going to do the following. Like this. Oh, I forgot to pass. Oh, right, it still needs an event args object, which in this case will just be, oops, an empty set of arguments. So what I'm doing here is I implemented a protected virtual method. We're not even actually going to make use of this method being virtual. We're not going to override it in a subclass or something like that. But this is how it's typically done, because this would allow subclasses of this class to override the behavior of how an event should be raised. So this way we could, in subclasses, provide different arguments, different parameters for the event handlers, which in this case we're not going to do, but by convention it's usually done like this. So with this method we can now raise an event, and clients can subscribe to this event by simply adding a method with a matching signature to this event handler, and then all of these methods will be called as soon as the invoke method here is called. So let's do that. So when should this method be called? Well, it should be called the moment that the T-Rex hits the ground when it's falling. So let's take a look here at our update method. Else if jump state equals jumping or falling. Here, right? If the position is greater than or equal to the start position, we basically set the position to ground level and put the T-Rex back in the running state. So yeah, this is basically when we need to call the onJump complete method to raise the event. So now every time the T-Rex hits the ground, this event will be raised, and now in our game class we can subscribe to that event and handle it. Let's see. Let's go into our load content method, because here we actually instantiate the T-Rex class. So here, let's go ahead and say T-Rex jump complete plus equals, and then we have to pass here a method with a matching signature, which would be a method that takes an object and an event args object as the parameter list, and doesn't return anything. And the simplest way to do this is just let IntelliSense handle that by pressing tab. There we go. And now Visual Studio automatically generated this method here, which I will actually rename, because I don't like my methods starting with an underscore. It's weird. Like this. And here's the method. So I just subscribed to this event with this method here. So this method will be called when this event is raised. I could go ahead and subscribe with some other methods. For example, I could use an anonymous method in form of a lambda expression like this, and then go, I don't know, so this would work. So every time the T-Rex has finished jumping, every time it lands, the console write line method would be called, but we don't actually want that. But we want this method here to be called. And here now we can do the following. We could check the state of the game. If the state of the game is transition, we will actually set the state to playing. And then we also need to set the speed of the ground. So or actually it's the speed of the T-Rex, right? So maybe for that, let's go into the T-Rex class, and here we're going to, let me just take a brief look. Yeah, let me just go here and create a new method and call it initialize. Initialize. And here what we're going to do is we set all of the properties and fields to a value that it should be whenever the game starts. So let's set the speed to, I don't know what the start value should be. We really have to sort of play with these values here. Let's start with maybe 100, I don't know. And what else? Well, maybe just to be sure, we're going to set the state to running, even though it already should have been set to running. But just to be sure, whenever the initialize method is called, we set the state to running. Maybe we should add some sort of guard here so that the initialize method cannot be called randomly, for example, like in the middle of a jump or something. Well, actually, let me see. First off, let's put this in a constant for cleaner code and call it start speed. And what else? Well, first of all, before we optimize this, let's go back into the game class and just actually call this method. There we go. And this this name here of this method is actually in a convention, even though it suggests here that I should rename it because it violates the naming rule. This is typically the convention for naming event handling methods. So basically it's the name of the object that the event belongs to, and then an underscore, and then the name of the event. So yeah. This should already work. Let's see. Let's start up the game. And now as soon as the T-Rex lands back on the ground, the ground should actually be moving. Yeah, there we go. But obviously 100 is a little slow, so let's go back in the T-Rex class and change that value. I guess 200 should be fine. Start it up again. I don't know. Let's see. Let's maybe go with 240. Start it up again. I guess. Kind of. Yeah. Let's go with that for now. I mean, we can change it at any point in time, so we're good. So yeah, let's go back into the T-Rex class. We were already in there. Yeah, so maybe we should kind of implement some sort of guard here, some sort of condition. I mean, we don't need to, but I think it would be a little cleaner, because now we could basically call this method whenever, even if the T-Rex is currently in midair. Yeah, I mean, whatever. Yeah, it doesn't really matter. Let's keep it like this for now. I mean, we could set a flag after the first jump, stuff like that, but Let's not overcomplicate things. Let's see. What else? What could we do next? Let me just start up the game real quick. Yeah, so obviously we need some obstacles to jump over. So maybe that's going to be the next thing. Yeah, I guess. Or maybe we should take care of the scoreboard. So basically we also need to draw this here. And also the clouds in the sky. Oh, we could do... It doesn't really matter what we do first. I think I kind of want to go with this first, with the high score, or generally this scoreboard here. And I think the score actually increases... Whoops, that's kind of loud. And I think this actually, the points that the score increases by completely depends on the speed of the T-Rex. So the faster I run, the faster I actually rank up points. So let's take another brief look at our class diagram here. It's been a while since I've seen this. So hold on. There we go. So we said that there's going to be a scoreboard class which implements the igame entity interface. And I guess that's exactly what we're going to do. So let's go ahead. Go into the entities folder here, right click, add class, and call it scoreboard. There we go. And let's see. I think we only defined two properties, score and high score. And I'm not sure if we should actually go with an integer for the score, because it makes it much easier to scale the score depending on the speed if we use actual decimal numbers. I mean, the display value, the actual number that is displayed to the user, that is going to be an integer. But I think we should store the score actually as a float or maybe a double. What I'm going to do is I'm going to split this. I'm going to set the score. I'm going to actually make it a double. And then I'm going to add a new property which doesn't have a setter, only a getter. And it's going to be of type integer. And I'm going to call it display score. Display score. I think that's a good strategy. Let me show you what I mean here. So let's go ahead and create a new property of type double. Call it score. And then another property of type integer, display score, and this will simply return the current score rounded down to an integer. So let's go math. Oh no, actually, yeah, math floor score, and cast this to an integer. So the display score will always return the score, but round it down to the next integer, or to the previous integer, I guess, and cast it to an actual integer. So if the score was 1.7, the display score would be 1. That's fine. Let's add another property. also of type integer, and call it high score, because the high score itself will be just always stored and displayed as an integer. There we go. Now let's see. Oh, we need to, of course, implement the igame entity interface. The compiler will tell us that we're not actually implementing this properly, so I'm going to click here, implement interface, and it will create some stubs. Let's actually make the draw order a constant value. It's basically UI, so it should be drawn on top of everything else. So that means let's go like with 100. Yeah, that should be fine. Draw, let's remove this throw expression here. There we go, and let's see, how can we achieve what we want to achieve? First of all, we need the texture. Let me open up the texture in Photo Filter. Okay, so I pulled up the texture file here in Photo Filter, and we're going to need to display these numbers here. These right here. So let's check the coordinates. So apparently, are they all of the same width? I certainly hope so. So if I start here at x coordinates 655, and then I go 10 pixels to the right, seems fine, and it's 10 pixels wide and 13 pixels high. So let's define that as a constant here. Let's say texture quartz x numbers, or let's numbers x was 655, and texture quartz number y is 0, and texture quartz number width is 10. We need the actual texture, so let's create a field of type texture 2D and just call it texture. There we go, and then let's create a constructor here right under the property declarations, and it will take a texture 2D as a parameter. Whoops. And then we will initialize the texture field with the texture that was passed to the constructor. There we go. Now let's maybe create a method that converts a single number into, a single digit into the appropriate coordinates in the texture. Yeah, let's do that. Let's create a private method and it will return point, I guess. And let's call it get digit texture chords. And we will pass in the actual digit, which I guess we could pass in as a char, so as a character. We could also pass it in as an integer. We don't actually need it to be an integer. We could go smaller than that. We could go with a byte. We can do whatever. So I guess it would be easiest to go with the integer. Like this. And then let's first check if the digit is actually between 0 and 9. So let's go if digit is less than 0 or digit is greater than 9. Let's throw an argument exception. Throw new argument out of range exception. That would be perfect. And pass in a message here. Or first off, pass the name of the parameter. And pass a message here that says the digit value, or the value of digit must be between 0 and 9. Something like this. So now let's go ahead and say, let's calculate the x position within the texture by simply using this value here and adding the digit multiplied by the width, I guess. Right? So if we pass 0 as the digit, we will get this value, which is the actual start, is where the numbers, the digits here start in the texture, so that would be correct. If we pass 1, you would add the width of 1 digit, which would give us this area here. Then if we pass 2, you would add the width of 2 digits, which would give us this area, so that should be correct. That's all right. The y position obviously would be simply the value of this constant. I mean, we don't actually have to declare a local variable for that, but let's just do it anyway. And yeah, I guess that's it. Let's just return this. Or maybe let's not return a point, but actually return a rectangle so that we get the full bounce within the texture. So let's actually make this return a rectangle and call it get digit texture bounce. Or we could call it texture rect or something like that. So now this will return a rectangle that represents the area within the texture that we actually want to draw in order to render a specific digit. So return new rectangle, and here we can pass the x position, which is pos x, the y position, which is pos y, the width is simply the constant, and the height is, oh, I actually forgot to define that. And I think it was 13. Let's duplicate this here. Say height 13. Okay. Let's pass this value to the constructor. There we go. And now we have a method which we can pass a digit to, ranging from 0 to 9, and it will give us the exact coordinates within the texture. Here which should be rendered to the screen. That's fine. What else? What next? We need to basically be able to split the display score value into the different individual digits. So if, for example, the display score is currently I don't know 498, we need to split this into the individual digits 4, 9, and 8 and render them to the screen. So let's create a method for that. Yeah, I guess let's just create a private method that returns an array of integers. We could also go with an IEnumerable of integers, but let's actually use an array so that we can get the individual elements within the array. Yeah, let's say private array of integers and call it split digits, and pass the actual number. Maybe we could actually put this method here. I mean, this is technically reusable. We could move this method here into its own class. But since we're not going to reuse this anywhere, I guess we can just leave it here. So let's leave it here for now. So how can we go? Let's say someone actually passes 498. How can we split this into individual numbers? Well, basically what we could do, for example, is simply convert this to a string like this. Like this. So now we have the number as a string like this, and we can get the individual characters of this string like this. So this will give us the first character, and then we could convert that into an integer. So let's go ahead. I think there should already be. Let's just check something here. Yes. Yeah, there's already a get numeric value. Yeah, we could do that. Yeah, I figured there's already a method that does that. So let's go ahead and simply yeah, let's do this. Declare a new array here of new integer array. Call it result, and it will be a new integer array, and the length will be the input string length, and then we will simply iterate over over this array. And go Now, this doesn't work because get numeric value returns a double. But since we know that the character is an integer, we can safely just cast it to an integer, I guess. And then here we can return the result. So now we can pass, like I said, for example, 498 as the value. We're going to convert this to a string, then create an integer array that is of the same size as the length of the string, so the number of characters in the string. Then we iterate over this array and set each individual element of the array to the numeric value of the current character. And this will give us the digits of the numeric value that we passed. Yeah, that's fine. So let's remove this here. And we need to draw this at a specific position. So let me fire up the game here again. Yeah, it should be drawn in the upper right corner. We can just define a constant for that, since it's not going to ever change, right? So let's see. Let's go into the game class and check the width of the window. Or actually, let's go into the scoreboard class, and let's not actually use a constant. Let's use a property. Let's create a property of type vector2. Call it position. And in the constructor, we will also add an argument of type vector2, name it position, and then initialize the position like this. And now we don't have to worry about where it's rendered on the screen. We will have the client of the class, which will be the game class, decide where it's going to be rendered. So yeah, for now, let's go into the draw class and say score digits equals split digits and pass the current score. Oh, current display score. So we get the individual digits of the current display score value. And then we need to render them. And we will render them at the position specified by the position property. Let's go for each integer. Let's get the texture coordinates by calling the get digit texture bounds method and passing the digit like this. This should give us a rectangle that represents the area in the texture that should be drawn. And now we need to render this digit. Let's go like this here. Int pos y equals position y. Oh, yeah, right. I'm going to explain this in a second. Yeah, let's call the draw method of the sprite batch, pass the texture, let's call it screen pos. Oh, I'm going to explain this in a second, I'm sorry. Pass it here. This should be fine. Okay, let me explain this. So first we get the individual digits, obviously. So then we get the current x component of the position. Then we iterate over the digits. And here we get the area within the texture that should be rendered, representing the digit. Then we define a new local variable for the position on the screen where it should be rendered. And for that, we're going to, oh, I think I mixed those two up. Yeah, we're going to use the posx value that we defined here, that we declared up here, and simply the y position of the position property. And then here pass these values to the draw method of the sprite batch, and then increase the x position by the width of the individual digits, so that the first digit will be drawn, so that basically they're drawn next to each other. That's it. And this should already work, I guess, if I didn't forget anything. I guess. I guess let's test it. Let's go into the T-Rex runner game class. Go up here, create a new field of type scoreboard. Name it scoreboard. And then go into the load content method and actually create an instance. Like this, pass the sprite sheet texture, and the position will be, let's think, obviously a new instance of vector2. And what will be the x position? I guess it will be the screen width, the window width, minus, I don't know. What is the width? It's 600. Let's say minus 100, I guess. Let's just play around with these values here. And the y position will be, I don't know, 10. And for testing purposes, I'm going to actually set the score to 498. And I just figured I actually forgot something, but let's test this for now. Oh, we forgot to actually add this entity to the game using the entity manager. So let's go here. Done. So now we added it to the entity manager. So now it will actually be drawn and updated. Let's start the game, jump, and there it is. And it actually does render the correct numbers. The positioning is not quite right, but close enough for now. Actually, we also need to render the high score if there is one. But for now, I guess this is okay. That looks fine. Let's take care of another problem here first. Obviously, we need to pad this number with zeros to the left of it. If you take a look at the actual game, the number is always shown with 5 digits. So we didn't get that right. So we need to do that now. Let's go into the scoreboard class. And I feel like I'm kind of rushing things here a bit, so sorry if I'm going a little too fast here, but this is not purely a tutorial, right? It's kind of a let's dev session or something like that. Okay, and anyway, if you have any questions, just put them in the comments. We always want to render 5 digits. So how could we achieve this? First of all, let's define a constant for that. We could go with a byte. It saves us a couple bytes in memory. You know what? Let's do it. Constant byte number digits to draw. I don't know. And initialize it or set it to 5. And here, in the draw method, no, actually in the split digits method, simplest way to achieve this is simply use the pad left method of the string class and say total width should be, and now I'm kind of regretting that we, oh no, that's fine. We call the pad left method of the string class, pass in the target number of digits to draw, and then we pass the 0 character as the second argument. So what this does is if the string is shorter than 5 characters, it will add the specified character on the left hand side to this string. So this should already get the job done. This should already achieve our goal. Let's start up the game. Jump. Yeah. It was actually that easy. Okay, perfect.